Okay, guys, back for the very last page of our study guide where we have all of these different types of energy, the definitions and examples. So mechanical energy. ME equals KE plus PE. It's the sum of potential energy and kinetic energy in a system of objects. So we're going to be adding these two together, which is what sum means. So anything that has moving parts, wind-up toy, gears, any type of crank on a machinery, shooting a basketball are all examples of mechanical energy. Kinetic energy is the energy of an object in motion. It's got to be moving for it to be considered kinetic energy. So anything that's in movement. My example was a rock rolling down a hill. So if we increase the velocity, which is going to be increasing the speed, we're going to increase our kinetic energy. If we decrease our velocity, we're going to decrease our speed, so therefore we're going to decrease our kinetic energy. Potential energy is the stored energy of an object, stored. There are three kinds, right? Gravitational, chemical, and elastic. So the example that I have here is a truck parked at the top of a hill, so no movement. Gravitational potential energy is the energy of an object that depends on the weight and the height above Earth. Now remember, we're going to remember those two go together because they visually look like they're spelled very close except for the W and the H. So we're going to remember that weight and height go together, that the higher you are off of the ground, the more gravitational potential energy, the more weight that object has, the more gravitational potential energy. So the example, a ball held above the ground. Chemical potential energy is energy stored in the chemical bonds between atoms. Chemical bonds. So there are going to be a couple here that are very similar, but these are the bonds between. So a carbon and a hydrogen and oxygen atoms forming a molecule, the bonds between those atoms. That's where your energy is stored. So food, batteries, gasoline, green plants are going to have that chemical energy as a result of photosynthesis, making their own food. So it has the potential to give you energy for mechanical energy then afterwards, for kinetic, after you eat that apple or you have that banana or whatever else that you are eating, you break down those bonds and the energy is released. You break those bonds, those energies are released. Okay, elastic potential energy that is stored in objects that are compressed or stretched. So it's going to affect the shape of that object. So a stretched rubber band, a coiled spring, that's where we had our trampoline, that's where we had our bow and arrow, our slingshot. When you pull back the bow and arrow, you have all of that stored elastic potential energy to convert to kinetic energy when you release it. So think back to the little rubber band lab we did, where we pulled the rubber band back, changed the shape of that rubber band. All of that stored potential energy converted to kinetic energy when we let go of it. Nuclear energy, energy stored in the nucleus of an atom. Okay, chemical potential energy are stored in the bonds between atoms. Nuclear energy is stored in the nucleus of the atom. Uranium being one of the atoms is split in nuclear power plants. Radiant energy, energy that electromagnetic waves carry. We're going to abbreviate that EM. So there are several waves in that electromagnetic spectrum we'll learn about next chapter. It's sunlight, visible light, microwaves, radio waves, are ones that we think about and use from the radiant energy that comes from the sun. Alrighty, sound energy. Energy carried by sound waves. So plucking of a guitar string, vibrating objects are going to produce that sound wave. Radiant energy can travel through empty space, but we're going to learn in our next chapter that sound waves cannot travel through empty space, cannot travel through a vacuum. Okay, electric energy. Energy carried by electric current. So anything that is plugged in, refrigerator, your iPad charger, your iPhone charger, all of that. If it's not plugged in, you're not going to get that electric energy. You are not going to be able to use that device. So it's carried by electric current. So the idea of a battery, what a battery will do is battery is chemical energy that is able to be converted to electric energy. Due to friction, mechanical energy, when you rub your hands together, it's going to cause thermal energy. When we did that in class, we rubbed our hand together and it felt real warm. That's due to friction. So thermal energy is the sum of kinetic energy and potential energy of the particles that make up an object. So it's going to generate heat. It's going to feel hot. So thermal energy, when you have some hot chocolate and your mug feels warm, then that is due to thermal energy. When you have soup and it's warm, that's due to thermal energy. So the particles are moving really fast, then it's going to generate a lot of thermal energy. The particles of that object, if they're moving really slow, then it's not going to generate, it's not going to generate a lot of thermal energy, and it's going to feel cooler. So the particles, if they're moving really, really, really fast, they are going to generate a lot of heat. Like with the energy transformation when we pop popcorn, it goes electrical to radiant, and the microwave heats up the particles within the popcorn and converts to thermal energy, and it pops that corn so that we have popcorn to watch our movie. So when you take anything out of the microwave, it's really warm because we have increased the thermal energy within that product, the popcorn or the soup or the hot chocolate, whatever it is that you are heating up. So anyway, guys, review the study guide, review your vocab, review the outline notes, definitely review that basketball paper from a couple of days ago that's sitting in your PDF. So review all of those things for our upcoming test, and you guys got this. You rock. Bye-bye now.